Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published just yesterday, which introduces a new framework that achieves over a 32% absolute improvement on hard coding problems. The paper is titled, Xolver, Multi-Agent Reasoning with Holistic Experience Learning, Just Like an Olympiad Team. So the core idea here is to stop LLMs from tackling problems in a vacuum. Instead, this paper proposes a framework called Xolver that creates a team of specialized AI agents. These agents collaborate, learn from past attempts, and use a shared memory, much like a human competitive programming team. This approach, which the authors call holistic experience learning, allows the system to build on its successes and avoid starting from scratch every time. And as we'll see later in the podcast, the results are pretty impressive. Alright, and these first results really showcase the power of this collaborative approach. The charts compare performance on two tough benchmarks: AME for math problems and Live Code Bench for coding tasks. On the right, we see the coding results measured by pass at 1, which is the percentage of problems where the model's very first attempt at a solution is correct. The Xolver framework, shown in the dark green bars, dramatically outperforms the baseline models. It achieves over 91% on Live Code Bench, a huge jump that really validates this idea of using a team of agents. Building on those results, this diagram shows us the how. It lays out the Xolver framework, which looks like a digital command center. A planner agent takes the problem and coordinates a team of dynamic agents. These agents don't just start cold. They pull relevant examples from an episodic retrieval memory. Think of this as the team's long-term library of past successes. As they work, their attempts are evaluated by a judge agent and stored in an intermediate shared memory, a kind of shared whiteboard for the current problem, allowing for iterative refinement. This table then breaks down the performance in more detail, comparing Xolver against a whole suite of other approaches. We see it stacked up against proprietary models, specialized models, and other reasoning frameworks. The key thing to notice is that Xolver, especially the Plus version, which uses that cross-problem memory we talked about, consistently comes out on top. Look at the bottom row. With a strong backbone model, which is the underlying LLM the framework uses, Xolver achieves over 98% on the GSM 8K math benchmark and over 91% on Live Code Bench, setting new records. So which parts of this framework are the most critical? This next chart helps answer that through what's known as an ablation study, where researchers systematically remove pieces of the system to measure their importance. The bars show how much performance drops when a component is taken away. And it's clear that multi-iteration, which is letting the agents refine their work over several attempts, is the single most important feature. Removing it causes a massive performance drop. The multi-agent teamwork is a close second. This breakdown really proves that every piece is essential. So to wrap things up, this research really shows that how a model thinks can be just as important as its size. The Xolver framework takes a foundational LLM, what's called the backbone model, and builds a collaborative team of agents around it. These agents use shared memory and refine their work, which is a powerful validation of what the authors call holistic experience learning. This approach is a big step towards AI that doesn't just answer, but truly problem solves. That's all for this week. Thanks for tuning in.